Hi everyone, I am Shivan Shukla, a second year undergraduate in CSE department at IIT Kharagpur, and in this video I am going to discuss the video editorial for the problem A Question by Lake. So first of all, let me explain you the summary of the problem statement. So basically we are given a sequence AKN which is defined as follows. AK0 is 0 and for AK1 and 2 it is K, and for all values of n greater than 2 it is concatenation of previous 3 values. So for example, for k is equal to 1, A13 is 110 and A14 it is 110 followed by 1 and another 1. Okay, and what we are asked to find? And we are asked to find the sum of digits of all subsequences of AKN modulo 1e9 plus 7. So let's begin with our basic approach. So consider this particular one. In how many subsequences it will appear and what will be its contribution in each occurrence. So if we are choosing this one, then rest of the 4 positions we have 2 choices. We can either choose them or we do not choose them. So basically for this particular one, it will appear a total of 2 to the power length of this string minus 1 times, right? And in each occurrence it will contribute a 1 to the total sum. Okay, and you can notice that this is not special to this particular one. It will happen with all other ones as well. Okay, so from this what information we can infer? That total sum of digits in all subsequences, it will be what? So each particular one, it will appear total of 2 to the power length of this string minus 1 times, right? And how many such ones are there? That is count n. I call it count n. Okay, and now you see, if instead of 1, if we have k is equal to 2, then each particular 2 will contribute a 2 in the total sum, right? So for a general k, what will be its contribution in the total sum? It will be k, right? So what will be the total sum? It is just how many times each particular k is occurring, that is 2 to the power length n minus 1, and what is its contribution in each occurrence, that is k, and how many such k's are there, that is count of k, right? So basically we have to find this value. Okay, so now if you observe using this given this recurrence, that count n and length of n, they also follow the similar recurrence. So count 0 is 0 because there is initially no k, and in 1 for n is equal to 1 and 2, they are 1, and for further values of n, they follow the same recurrence, and similarly for this length n also. Now if you notice the constraint for the problem, so the number of test cases is quite high and n is also up to 1e5. So it is not possible to calculate these values for a particular test case. So this gives a hint that we have to do some sort of pre-computation, right? So what we can do instead, we can just pre-compute all the values of length n and count n for all n up to 1e5, and after that we can use them for each test case, right? So count n you can easily compute, and after calculating length n, then for calculating 2 to the power length n minus 1, you have to use Fermat's theorem. In case you don't know Fermat's theorem, so I have an alternate solution for you. So consider Gn as 2 to the power length n minus 1. Now what do we know about length n? That it is sum of its previous 3 terms, right? And if you do some sort of manipulation here, that if you adjust minus 1, minus 1, minus 1 here and plus 3 here, so plus 3 minus 1 becomes 2. And now if you notice, what is 2 to the power length n minus 1 minus 1? That is nothing, just g of n minus 1, right? Similarly, this will become gn minus 2, this will become gn minus 3, and this 2 to the power 2 will come as 4. So now you can easily compute gn using this recurrence, right? So now let me show you the code. Okay, so first of all, I have defined 2 arrays of long int size f and g, Fn is same as the content which I have explained. Gn I have already described earlier. So first this function builds the f. So f0, 1 and 2 I have described earlier and using the recurrence. Similarly we build g, but here you need to take a precaution that you can't multiply the three terms together as it may exceed the value of the max value of long int. So you have to do in two steps. Then finally we are taking the input. For each test case, we already have computed fn and gn. So we just need to multiply them together and finally multiply it with the k and print the answer. So that's all for this video. If you have any doubt, feel free to ask in comments, and thanks for watching.